Good afternoon. Just wait for 5 minutes. Let the other student join. By the time the students are joining, yes.
Lunch, sir.
Lunch. Yeah,
Yeah,
done.
sir.
What about you people?
Yeah, sir. Just now we had.
Okay. So by the time students are joining, can you tell me what is the topic of today's lab? Yes. Anybody have seen the invitation in which the title of
Non-destructive testing.
non-destructive testing? Yes, Kishore, can you tell me what is non-destructive testing?
No idea, sir.
Anything from the name itself, you can make a gentle guess. Yes,
Sir,
Rohit. Yes, yes, Kishore, tell.
uh, it is the testing for stability, structural stability, and it.
By the time till now, how many experiments you have done? Can you tell me the name of those experiments? Yes, Kishore. Can you tell me the
Yes,
name of those experiments that you have performed in the college?
sir.
Yes, Junaid, Fazal Junaid. Yes, Fazal Junaid. Junaid, are you there? Sachin. Sachin. Yes, Sachin HB. Sachin, are you there? Hello? Sachin, are you there? Okay, anybody can tell me what are the experiments that you have performed in the college before this lockdown? Yes, anybody? Yes, Harsha. Harsha,
Yes, sir.
can you tell me the name of the experiments that you have done in the college before this lockdown?
Sir, shear force
Yes,
and bending moment,
yes.
and we have another two experiments. Sir,
You have done the hardness testing, is it?
Yes, sir.
You have done Rockwell hardness, Brennan hardness, and Vickers hardness. You have done the tensile testing, is it?
Yes, sir.
Okay. So in all the experiments, you have seen one thing: the sample that you are going on which you are going to perform the test, it is broken, or it is undergo some sort of deformation. When you are doing the hardness test, you are making the indentation on the workpiece. So what will happen? You can no longer use that specimen for the use. Okay, because you have destroyed that specimen. You have performed the testing and you have made indentation on that particular specimen. So all those testing in which the sample is destroyed and not fit for use, so that type of testing is known as the destructive testing. But today we will look into some other aspect of testing, that is the non-destructive testing. In this type of testing, we are not actually destroying the sample. So if you want to use your sample for the further use, you can do it. Okay, so have a look. So we will look into different types of non-destructive testing that can be used in order to predict the flaws or material properties. Okay, so let me share the PPT with you. Okay, here it is. Okay. Okay. So can you see the PPT? Yes. Can you see the PPT?
No, sir.
Okay, fine. So today we are going to discuss another aspect of testing, that is the non-destructive testing. Okay, so we will start into that. Okay. First, you see here. Okay. So first, non-destructive testing is the method in which material properties is evaluated without destroying it. So here what we are doing, we are not going to destroy the specimen in which we are going to perform the test. So without destroying the specimen, we are going to perform the testing. So that's why this type of testing is known as the non-destructive testing. So non-destructive testing is also written as NDT. It is commonly known as NDT. So it is the quick, means you can perform the analysis about the properties very quickly. Then reliable means it can be, you can make a belief on this, means it is reliable. Okay. And the next is economic, means less costly. So NDT is the quick, reliable and economic method of material properties evaluation. So if you have seen the destructive testing, there you are using, suppose let's take the example of this universal testing machine. So that is a very heavy machine. It is costly also, and in order to perform the test, suppose you want to measure the various properties like yield strength or tensile strength, so it will take time. So first you have to prepare the sample according to the ASTM standard, then you have to load the sample, then you have to apply the load, and then you have to wait for this stress strain curve to get plotted, and then finally from that graph you will be able to predict the yield strength, tensile strength or other associated properties. So here in NDT such type of involvement is not there. It can quickly predict the material properties. Okay. So this method can be used for quality inspection in different stages. So this NDT methods, non-destructive testing methods, can be used in different stages. So what are the different stages? So suppose if you want to make a product, so what is the first stage? The first stage is the production. Okay. So you have in the production stage, you can perform the testing using this non-destructive testing method. Means after producing the component, you are supposed to be ensure that your product is not faulty. Okay, for that you have to perform test. So either you go for the destructive test, that will take a lot of time, or you can go for the non-destructive testing that we are going to discuss today, so that you can predict whether the part that you have manufactured is free from defect. So first stage, production stage. After manufacturing the component, you are going to check whether your part is okay or not. The second is service life of the material. Suppose you have manufactured a component and you have installed, you started using that product. So what will happen as the time passes? What will happen? The quality of that product will also get deteriorate. So what you will do? So using non-destructive testing method, you can inspect the remaining service life of the product. Suppose you have make a product, and if you are using that product for 5 years, then you can perform the testing and you can predict the rest life of the, or you can predict the how the properties are changing with the time period. Next is the to assess the reason in case of material failure. Suppose you have make a product and finally after a long term of operations it gets failed. So in order to find the probable reason why this material failure occurs, so in order to ensure that, you can also go for the non-destructive testing. So here you can use the non-destructive testing in order to evaluate the flaws or defect or properties in different stages. So what all are the stages? The production stage after manufacturing the component. Second is the service life of the material when the product is actually in use. So also you can perform this non-destructive testing in order to tell that what sort of deterioration has taken place and how the properties is changing with the time. To assess the reason in case of failure, as I already discussed, so in case the on continuous using that product, if the material gets failed, so you can also predict the cause of failure, why this material fails using this non-destructive method. So you can see here okay, so here you can see this is the eddy current testing of rails. So you can see this is the railway line, and with many of the rails means after passing through this railway line, what will happen? The properties will going to be changed. So in order to measure that property, means what effect uh, on this railway line is going to happen after continuous use of this rails. So in order to monitor that changes, we can use here this eddy current testing. Second example, you can see that here what we have done, here welding is done. So during the welding, because of improper control on the process parameter, may be possible that some sort of defect or remains inside the weldment. So in order to find that weld defect or associated changes in the material properties because of that welding, so what you can do, you can also use this non-destructive testing. So today we are using this non-destructive testing in various areas of manufacturing. Okay, then we will see the what are the advantages and disadvantages of this particular non-destructive testing. So first we will see the advantages of NDT, non-destructive testing, and then we will look into the disadvantage of non-destructive testing. So let's first look at the advantage of non-destructive testing. So the first advantage is it helps in sorting of defected components, thus increasing the manufacturer reputation. So suppose you are having an industry of producing steel cups. Okay, so you don't want your customer to get the faulty product. So if any of the cup that you have manufactured, by default it reaches to the consumer, then what will happen? The consumer will lose faith on that particular industry. So no industry wants that consumer is going to get any defected component. So using this NDT methods, you can sort out the defected components. So because if you are producing in large amount, so if you are going for this destructive testing, it will take lot of time. So also if time is equal to money, so eventually the cost of that particular product is going to increase. So that task you can perform using this non-destructive testing. Okay, so by using this testing methods, we can make the sorting of defected component. and thus increasing the manufacturer reputation. So if you are able to sort each and every defected component, that what will happen? So the defected component is not going to reach to the consumer, and so what will the consumer will be happy and have a good faith on your industry. It helps in ensuring the product performance during operation. Okay, so suppose you have made a machine. Suppose you have made a machine and that machine is under operation. So by using continuous operations on that machine, what will happen? The properties is going to change. The performance of that particular product is going to change as the time period passes. So in order to evaluate the performance, means whether the product is performing well or not, you can perform this non-destructive testing. It also helps in reducing cost of product by eliminating scrap. Okay, so suppose you have an industry, again let's take an example that you have a cup industry. So if you are going to, suppose you are going for the destructive testing, so what will happen? The component on which you are going to perform the destructive testing, what will happen? You cannot use that component again, means you cannot sell that component to the consumer. You have to maintain it as a scrap. So that is the loss of material, also the lot of the loss of the wealth for the that particular industry. But in non-destructive testing, we are not actually going to destroy that particular component for the testing. So we can reuse that particular product, or even you can sell that product to the consumer. So the cost is reduced because scrap has been removed. Next, it helps in design of new products. Okay, so if you want to design any new products, so at each and every steps, you can go for the non-destructive testing, and this eventually will help you in the designing of new product. Coming to the disadvantage of non-destructive testing, the only disadvantage associated with this non-destructive testing is, in comparison with conventional method, the operation of advanced instrumentation requires a higher level of training and additional certification, which incurs more cost. In a very simple way, I can say that what does it means, that you are supposed to require a very high skilled labor or very high skilled trainer in order to perform this non-destructive testing. It cannot be performed by a semi-skilled operator. Okay, then we will look into the different types of non-destructive testing. So okay, so here you can see that we are having many types of non-destructive testing. Okay, so here you can see these are the various non-destructive testings that are very popular today. Apart from this, there are many more also that is known as the advanced non-destructive testing. So here the first one that we are going to discuss is the visual testing. So visual testing is there, acoustic emission test is there, magnetic particle test is there, radiographic test is there, liquid penetrant test is there, infrared thermography, ultrasonic test, and eddy current testing. So these are the some of the common non-destructive testing. So in this class, so in today's class, we are going to see the non-destructive testing that is been shown in red color. Means we are going to see the visual testing, magnetic particle testing, liquid penetrant test, and ultrasonic test in the today's class. Okay. So first we are going to see the visual testing. What this visual testing means the defects that you can see by your naked eyes. Okay, so suppose this is the casting product that you have made and you have seen this defect, pinholes. So if you are able to see these defects by your naked eyes, so there is no need to perform the further test. You can simply reject this product, or you don't need any sophisticated non-destructive testing method in order to reject this part. Simply by saying that seeing this part by your naked eyes, you can say that this is the pinholes defect, so this part will not qualify the test. Okay, here also you can see shrinkage defect. Here you see the material is unable to fill here, so here you can see here there is a formation of shrinkage defect. So this defect also you can see by your naked eye. Perform any test for this, you can simply see that there is a shrinkage defect, so also this product is not going to qualify the test. You will simply remove this product from the lot. Here also you say you have performed a welding here, and you can see this is the solidification cracks. This is the solidification cracks appears on the weldment. So simply by seeing by your naked eyes, you can say that this is the defect. So you are not going to qualify this product for the further application. So the first type of non-destructive testing is the visual testing. By we can test the material by our naked eyes. Okay. So visual inspection is a non-destructive testing used to detect various surface discontinuities through naked eyes or with some technological help. Suppose this you are not able to see this, so by taking the help of some lenses, you can able to see this. So or with some technological help. So by taking the help of some lenses, even if you are going to have this very small size pinholes, you can also see that holes. So the first type of testing is the visual testing, which we can perform by our naked eyes. Simply by seeing through our naked eyes, we can say that whether the defect is there or not. So for these type of defect, we can simply by seeing through our naked eyes, we can say that this have defect, and that's why these products are not going to qualify for the next stage. Various defects occurs in welding and casting can be visually inspected. So in especially in the casting and welding, so many of the defects I have explained you people by your instructor. I am not taking PT1 class in your section, but still they have talked about this welding and casting defects. So many welding defects that you have studied previously in the module 1 and module 2 can be inspected visually. Simply by seeing through your naked eyes, you can say that whether the defect is there or not. Another thing about the visual testing is it is a very economic way of detecting defects. Okay, so here you don't need any sophisticated instrument. Simply you have to see by your naked eyes. So it is very economic also. So no cost involvement is there. If you are going to take involvement of some technological help like lenses, even though the cost will be involved for the lenses, but that too it is very low. Next is magnetic particle test. Okay. So in magnetic particles test, you can see that it is a non-destructive process which is used to detect surface and subsurface discontinuity in ferromagnetic material. Here one thing to note is that it is only applicable for ferromagnetic material, and it is able to detect surface as well as subsurface discontinuity. Subsurface means below the surface. Okay, but open to the atmosphere. Okay, so it is a non-destructive process which is used to detect surface and subsurface discontinuity, means any crack or defect in ferromagnetic material. Okay, so see what we do in this testing is, suppose we are having this specimen and here we are having crack. So this crack is been shown in larger view, but actually this is very small cracks that is not visible by our naked eyes. Okay, so what we do is we are going to apply the magnetic field on this whole of this specimen, and then we will sprinkle magnetic powder. Small, very small size magnetic particles are blown on this specimen. As we have applied the magnetic field, so if there is crack persist, if there is any crack is present inside the material and that is open to the atmosphere, what will happen? There will be the leakage of this magnetic field. So what will happen? All these magnetic particles is going to fill in this particular crack, are going to move near to this crack because of this magnetic flux leakage. Okay, so this technique is simple to operate. So this technique is very simple. Simply we have to apply the magnetic field on the this specimen that is to be tested, and then, and also it does not require any sample preparation. We don't need any special sample preparation for that. As we have seen in the case of the destructive testing, we are supposed to follow the ASTM standard in order to make the specimen for the particular type of test. Okay. This test requires magnetic field and iron particles to detect the flaws or discontinuity. Okay, suppose this is the discontinuity. So what I have told, we have to apply the magnetic field and then we have to sprinkle the magnetic particles. Okay, so here what is the requirement? We need an apparatus to apply the magnetic field and we need the iron particles. So these two are the requirement are there for the magnetic particle test. With these two only we can perform the testing of this specimen. If there will be any cracks or discontinuity on the surface or on the subsurface, we will be able to predict the cracks very easily. Okay, so here I'm going to show you the how this magnetic particle testing work. Just a minute. We are not able to play this. Just wait for a minute. So if there is any network issue, then if the meeting is going to end, then please rejoin it. Okay, the moment I will start again. So please just wait for a minute. I don't know why this video is not working. Let me. So, Hello, can you see this screen? Hello,
Yes, sir.
can you
Yes,
see
sir.
magnetic particle testing?
Yes, sir.
Okay, so
Right, sir.
you can see here, this is our workpiece, okay, which have to perform the, on which we have to perform the test. Okay, so here he has taken a instrument that is used to generate the magnetic field. You can see here, this way, because this is the weld which we have to test. So around that weld he is going to generate the magnetic field using this yoke. Okay, this is known as the yoke. Now he is just this spreading this magnetic particles on the weldment where the welding has been done. Now this is to remove the excess ferromagnetic particles or iron particles. So wherever there is crack, so that particles will going to get and filled into that particular crack. You see, this is the, we are removing the particles. Now again spread the this ferromagnetic particles or iron particles. Now you can see here, you can see from everywhere these particles get removed, but this is the portion. So here you can see that here the crack is there because the magnetic particles is going to fill here. Because if you are applying the magnetic field here and ferromagnetic particles or iron particles is there, so because of the magnetic field leakage, so all these particles will get into get and fill this crack. So that will remain and that will tell us that there the crack will be there. So this is how the magnetic particle testing works. Okay. The next method of non-destructive testing is, just a minute, why it is hanging. Okay. So the next method is liquid penetrant test. Okay. So this is the another type of non-destructive testing. So in the visual testing, you have also seen that we are not going to disturb the or destroy the workpiece. In the magnetic particle testing also, you can see that we are not going to destroy the workpiece. Okay, if there will be crack, then that will tell us, otherwise we can use that particular product for the further use. So the next type of non-destructive testing is this liquid penetrant test. So liquid penetrant is also called dye penetrant test. Okay, here because in this we are using a